All right, students. So today we are going to review the questions from acid and bases. So it would be great if you take out your handout and go through the questions with me. Remember, you can play and pause the video anytime. So if you don't understand something, pause the video and then go back, review the question, and then listen to the video lesson again before you move forward. So let's get started. The first question we have is which solution is the best conductor of an electric current? So they gave you four options and we have to pick the best possible option. In these options, you can see that they gave you two information, something about mole and then volume in terms of milliliters. So think about what you know in terms of conductor of an electric current. So if you're thinking about electrolytes, most probably you are in the right direction. So we know that acids, bases, or ionic substances are good electrolytes. If we have more ions in a solution, then we will have a better conductor of electric current. If we have less ion in a solution, we'll have poor conductor of an electric current. So out of those four options, we have to figure out which one has more ions in solution. So the first one, you have 0.01 mole in 1000 milliliters of water. The second option, you have 0.005 mole in 1000 milliliters of water. So right away, I can cross out option 1 because in option 1, I have less mole in 1000 milliliters of water. If I consider B and C, for option C, I have 0.1 mole in 1000 milliliter of water. So if I'm comparing B and C, I can cross out option B. And then I can also cross out option D as well because all of these options have less mole in 1000 milliliter of water. So the only option that would make sense is option C, where we have 0.1 mole in 1000 milliliter of water. So we have 0.1 mole of NaCl, and that NaCl, when we place NaCl in water, it breaks apart into Na plus ion and Cl minus ion. And those ions will help conducting electric current. For question 2, we have to figure out which formula can represent hydrogen ions in an aqueous solution. So you have to think about the definition of an acid and base, right? So which one produces hydrogen ions? Is it acid or is it base? So only acids can produce hydrogen ions, right? We call it hydronium ions. And if you look at reference table E, this is where you're going to find all the polyatomic ions. And based on the Arrhenius theory, we should know that a substance is going to be known as an acid if it produces hydronium ion or a hydrogen ion. Another name of a hydrogen ion is proton. So this is a basic straightforward definition of an Arrhenius theory of an acid. For question number 3, which compound is an electrolyte? When you're answering those questions, I would highly recommend you to use reference table K and L because we need to know that ionic substances, acids, and bases are electrolytes. So if you look at table K, we have common acids. If we look at table L, where we have common bases, most probably your region's answer will be in one of those two reference tables. Now, if we look at table K and table L, we'll find H3PO4, which is phosphoric acid. And if it's an acid, we know that it should be an electrolyte. And that should be our best possible answer for question number 3. So do not make things complicated for these type of questions during regions. All you have to do is first take a look at reference table K and L, both reference tables. And if one of the options is there, then you just pick that option. So question number 4 is very similar. So we have to figure out which ones are electrolytes. So again, we have to look at reference table K and L. Please go ahead and figure it out by using reference table K and L. Make sure you pause the video at this point and then play it back again to check your answer. So if you went through the options, most probably in option A, you will find KOH, which is potassium hydroxide. You can find it in reference table L. And then you can also find CH3COOH in reference table K, which is acetic acid or ethanoic acid. So option A has an acid and a base. And as we should know that ionic substances, acids and bases, all of these are electrolytes. And therefore, option A for question number 4 is our best possible answer. For question number 5, we have to identify two H plus donors or two proton donors. So if you go back to the original definition of an acid and base, right, based on alternate theory or one acid base theory, acids are protons donors. So we're looking for acids. If we're looking for acid, we have to figure out two acids based on the reaction. So one would be regular acid, the other one will be conjugated acid. So let's not make things too difficult. Instead, we should think as if like a fifth grader. So look at the first part from your left side of the arrow. So that's the arrow. So look at the left side. Here we have CH3COOH. At the end of the reaction, it became CH3COO minus. So clearly, it gave away H plus ion. And therefore, CH3C double OH is an acid because it donated a proton. If you look at H2O, what happened to H2O after the reaction? H2O gained that proton and became H3O plus. So H2O was a base and H3O plus is a conjugated acid of H2O. So now H3O plus can donate an H plus proton and therefore it is also going to be considered as an acid. So we have two acids. One of them is acetic acid, CH3COOH, and the other one is hydronium ion, which is H2O plus. So both of them are acids and both of them can donate H plus ion. For question number 6, they're asking you according to one acid-base theory or alternate theory, the forward reaction is classified as an acid-base reaction, right? And you have to give them a reason. Why should we consider the given reaction as an acid-base reaction? Let's start taking a look at the left side first, left side of the arrow. We had H2S. What happened to H2S after the reaction? If you consider just the letters, we had H2, meaning 2 hydrogens and 1 sulfur. After the reaction, we only have 1 hydrogen and 1 sulfur. So what happened? We lost a hydrogen ion. So H2S is a hydrogen ion donor or proton donor. On the other side, we have CH3NH2. After the reaction, what happened? If we compare this, we have CH3, same as before, but instead of NH2, we have NH3 plus. So it seems like from the left side, we have CH3 and H2 gain the same exact proton that was donated by H2S. So this is the reason it's an acid-base reaction, because one of them is donating the proton while the other one is accepting the proton. And therefore, option A would make more sense, where H2S is a proton donor, while CH3NH2 is a proton acceptor. For question number 7, sorry. The question is based on Arrhenius theory. So remember, according to Arrhenius theory, acids produce hydronium ion and bases produce hydroxide ion. So they're asking you, when potassium hydroxide, focus on the word hydroxide, dissolves in water, the only negative ion in the aqueous solution is. So what is hydroxide? If you remember what hydroxide is, that would be great. If not, please take a look at reference table E and find the word hydroxide, and you'll realize that hydroxide is OH minus. Potassium hydroxide is a base that can be found in table L, common bases. And if you dissolve any base in water, it will produce hydroxide ion. Right? Some bases, not all of them. So therefore, the correct option would be option D for this question. All right, so question number 8. Here we have to identify water molecule, and they're telling you it's a base. And if you remember alternate theory or one acid-base theory, acid donates proton and base will accept proton. Right? That's something we know. And another name of proton is H plus ion. Let's just say we forgot all of these. Then just look at the left side of the equation where we have water, and then track it down on your right side. So what happened from here to there, right? We had H2O, meaning 2 hydrogen, 1 oxygen. After the reaction, we have 3 hydrogen and 1 oxygen with a positive sign. That means water accepted a hydrogen ion or proton, because otherwise it won't be H3O plus, right? So if you literally think about how many hydrogens we have, how many oxygens we have, from your left side to your right side for water molecule, since it became H3O plus, that means we have an extra hydrogen and with a positive sign. And that means water accepted a proton. Question number 9. According to one acid-base theory, meaning alternate theory, NH3 acts as a base. So they're already telling you NH3 is a base, so it should accept a proton. So that means NH3 will accept a proton, which is H plus, and that means it would form NH4, so 3 and here you have 1, so NH4 with a positive sign, right? So it will form NH4 plus. So if NH3 acts as a base, then if it's a base, you need to know this. According to our alternate theory, bases will accept proton, and therefore the first option would make more sense. All right, question number 10, where we have to focus on the word neutralization. What is neutralization reaction? We have acid reacting with a base to produce salt and water. Acid donates all the hydronium ions. Bases will produce all the hydroxide ions, and these two are used to produce water. So which one is a neutralization reaction? So again, I would highly recommend you to use reference table K and L both, because table K is where we can find all the common acids, and table L is where we can find all the common bases. So we just have to figure out if we have an acid and base in one of those reactions, which will produce salt and water. So if you go through reference table K and L, you should be able to find the correct answer. So please pause the video before I reveal you the correct answer. Now, if you look at your reference table, calcium hydroxide, you can find it in reference table L, and then H2SO4, sulfuric acid, you can find it in reference table K. Together, they form water and salt, and therefore option C is the best possible answer. You can also eliminate option A because it didn't form any water, right? Options D as well didn't form any water. Option B seems like form water, but O2 is not a base or acid. CH4 is not an acid or base. So these options doesn't make sense. So we can use the process of elimination. The best way to solve this question is use reference table K and L. Question number 11. Similar to question number 10, so you should practice this question by yourself by pausing the video and then play again just to confirm your answer. Again, use reference table K and L. If you use reference table K, you would realize that H2SO4, sulfuric acid, is there, and potassium hydroxide is in reference table L. So sulfuric acid will donate all the protons, which is hydrogen ion, and potassium hydroxide will give away all the hydroxide ions to form water, which is something neutral. And then potassium and sulfate are going to produce H2SO4. And therefore, option C is the best possible answer for question number 11. So question 12, here we have to complete the equation by writing the formula of the missing product. So MgOH2, that's a base because again you have hydroxide in it. And they also use the word neutralize, right? So you should know that it's an acid-base reaction, neutralization reaction. If you look at reference table K, you will find HCl, which is hydrochloric acid. So this one is an acid. So the question is, we know that if we have acid and base together, we form salt and water. Water, right? How do you produce water? So the way we produce water is by having all the hydroxide ions from bases and then by having all the hydronium ions or hydrogen ions from acids. Together they form H2O, right? So why don't we eliminate all the hydroxide that we have from the base, eliminate everything, all the hydroxide, and why don't we eliminate all the hydrogen ions from the acid? So now you'll realize that we have magnesium and we have chlorine. If you look at the oxidation state number from reference table page 9, magnesium has +2 oxidation state number and chlorine is -1. And you might realize that there are 2 chlorines in here that you need to consider, or you can also realize by looking at their oxidation state number. It's not balanced yet, so +2 -1 doesn't add up to 0. That means you need another chlorine in this equation, and therefore the chemical formula between magnesium ion and chloride is going to be MgCl2. You can also do crisscross method if you know what that is, where you can have those oxidation state number and then use the crisscross method. You write magnesium and chlorine next to each other. This one will be right here at the bottom as a subscript, and this too will be there for chlorine as a subscript. So either way, you will get MgCl2 for the missing product, which is the salt in this case for this acid-base neutralization reaction. Question number 13 is very similar to question 12. They gave you an equation. You have to figure out the product. Remember, HCl is an acid based on reference table K, and KOH is a base based on reference table L. So you know that we are going to produce water. So we're going to produce H2O. How do we produce H2O? By removing all the protons from the acid, which is HCl, and by removing all the hydroxides from the bases, which is OH. So we left out with K and Cl. So if you look at reference table page 9, K, the oxidation state number, top right corner number for K is +1 and Cl is -1. So that means the ratio is 1 to 1. So the salt in this case would be KCl. So for question number 14, you are using an indicator, which is bromocrystal green, and the indicator is used in a sample of KOH. So again, you need to know at this point KOH is a base. If you don't know, you can look at reference table L, potassium hydroxide. And we need to understand that usually we have bases. The pH of any basic solution is usually about 7, right? So bromocrystal green is going to show 2 colors. It would be yellow for any solution that has a pH of 3.8 or less or lower, right? And it would be the color for bromocrystal green is going to be blue for a solution that has a pH of 5.4 or higher. So since potassium hydroxide is a base, which should have a pH of 7 or higher, therefore the solution color is going to be blue. So if you are using bromocrystal green in a basic solution, the color should be blue because the pH level should be 7 or higher. And if you are using bromocrystal green, a solution that has a pH 3.1 or lower, then the color is going to be yellow. Since we are using potassium hydroxide solution, if we use bromocrystal green in that solution, the color that we will be observing is going to be blue because it's a basic solution. For question number 15, we have to identify the pH of a solution that is 10 times less acidic than the hydrochloric acid solution. So first we need to know the pH value of the hydrochloric acid, which happens to be 2 based on the question. We can see it right here. That means we are looking for a solution that is less acidic. In other words, we're looking for a solution that is more basic or towards our right side. This is something you need to understand before we move forward. So if a solution is less acidic, in other words, it means the solution is more basic than the solution that we are comparing. So we are looking for a solution that is on the right side of a solution that has pH 2. Since it says 10 times less acidic, that's the factor. And if you look at the factor, after 1, we only have 1 0, right? 10. And therefore, each pH unit, we need to remember that each pH unit signifies a tenfold change. So if there is only 1 0 after 1, right? That means the difference between those two solutions in terms of pH is going to be only 1. So we're looking for a solution that has a pH of 3. If you think about this, pH 3 is 10 times less acidic than pH 2 solution. Even though pH 2 and 3 are both acidic solutions, pH 3 is still 10 times less acidic than solution of pH 2. So question 16 is very similar to question 15. We have to identify the pH of a solution that has hydronium ion concentration 10 times greater than the original NaOH solution. So we're looking for a solution that has 10 times greater hydronium ion concentration than the original one, right? So if it's 10 times greater hydronium ion, if it has 10 times greater hydronium ion concentration, that means the solution, the new solution would be towards our left side compared to the previous solution, right? Because left side is more acidic compared to the right side. Right side of our number line in this case would be more basic. So our original solution is 13, pH 13, which is, let's just say right here. If I'm looking for a solution that has more acidic ion concentration, that means I should go towards my left side. But I have to focus on this number right here. If it says 10 times, I have to remember that in 10, the number 10, after 1, you have only 1 0. That means you're moving only 1 pH unit. So the solution that will have 10 times more acidic ion concentration than pH 13 would be pH 12. So the answer is going to be pH 12. So for question number 17, we have to state the color of phenolphthalein indicator if it were added after the hydrochloric acid was titrated with 50 milliliter of sodium hydroxide. So after titration, after reaching the equivalence point, the pH of the solution is above 9. And we know that phenolphthalein, based on reference table M, will be colorless for any solution that has pH of 8 or lower. However, it will be pink if a solution that has a pH of 9 or higher. So if the indicator was added after its hydrochloric acid was titrated with 50 milliliter of sodium hydroxide solution, then the pH is going to be above 9, and therefore the color that we are going to observe is going to be pink. For the second question, question 18, based on the graph, we have to identify the volume of sodium hydroxide used to exactly neutralize HCl. So if you look at the initial pH, we started with a very acidic solution. pH is 1. And then after the reaction, we had a solution that has pH above 12, right? Which is actually basic. So when we have the word neutralized, right, that means we are reaching a neutral pH. Generally, it is 7. And at pH 7, we have to figure out what is the amount of sodium hydroxide that we used. The amount of sodium hydroxide was used at pH 7. In this case, it seems like exactly 25 milliliter. So for pH 7, if you follow this line, the amount that we got is 25 milliliter. A student can answer 24 or 26 during the Regents exam. 25 would be the best possible answer for this question. For question number 21, we have to identify the hydrogen ion concentration of solution B. If you look at solution A, they gave you a hint. You have to review pH values, right? If you don't remember how to solve this question. So when pH value is 2, look at the hydrogen ion concentration. The hydrogen ion concentration, usually pH is negative log of hydrogen ion concentration. So when the value was 2, the pH was 1.0 times 10 to the power. I'm going to change this color, focus on the color. So when the pH was 2, the hydrogen ion concentration was 1.0 times 10 to the power negative 2. That's the number we're looking at, the exponent. So similar way, if you have something that has a pH value of 5, then the hydrogen ion concentration is going to be negative log of H plus, which happens to be 1.0 times 10 to the power negative 5. It is that simple. So if you have, look at the pH value, and the hydrogen ion concentration is going to be 1.0 times 10 to the power negative and that number. You can use your calculator to solve this question as well. But this is the simplest way to solve question number 21. For question number 22, we have to state the color of methyl orange indicator in a sample of solution A. So if you look at solution A, methyl orange, based on reference table M, only can produce two different colors. It would be red for a solution that has a pH of 3.1 or lower, or it would be yellow for a solution that has pH of 4.4 or higher. So for solution A, the pH is 2, which falls under the category of 3.1 or lower, and therefore color that we will be observing is going to be red for solution A. For question number 23, identify the negative ion for sodium hydroxide used in titration. Again, it's a classic acid-base question, theory question, where you need to know that based on Arrhenius theory, um, bases produce hydroxide ion. And if you look at reference table E, NaOH will produce OH minus, or another name of OH minus is hydroxide. So it will produce hydroxide ion. This is a very straightforward classic acid-base theory question. For question 24, the keyword is titration. Always underline the keyword. So the moment you know that it's a titration problem, go to reference table T and please copy the formula down just like the way I did. Right? So don't take any shortcut. Then you have to look for what is given, and based on the question, we need to identify the molarity of HC2H3O2, which can be found in reference table K. Another name of this compound is acetic acid. You can call it ethanoic acid as well. But if you look at the question, we have to figure out what is given, right? So then I noticed NaOH. Always look at the unit. It would give you a good idea of what is given. So 0.3 capital M stands for molar concentration. So 0.3 m, and NaOH can be found in reference table L, which is a base. So the concentration of the base is given. Next to the concentration, we have 43.1 milliliters, so that must be the volume of the base. So I already know the concentration and the volume of the base. I know that I have to figure out the concentration of the acid. So the only thing left over is to figure out the volume of the acid. And if you look at this part, this 50 milliliter of a sample of vinegar, and that's the acid in our case. So 50 milliliter must be the volume of the acid. So set up the equation. We don't know Ma. Ba is 15. M MB would be 0.3, and VB in this case is 43.1. So please plug those values. So for MA by dividing both sides by 15, and therefore you will get, if you solve it correctly, you will get the concentration of acid would be 0.862. Any answers like 0.86, 0.862, all of these would be correct answers. So for question 24, we got an answer as 0.862 or 0.86, right? Or some people might write 0.9. Now the question is, how do we round our answers, right? That's the most common question. According to like science, you should always look for the correct number of significant figures, right? We usually don't talk about, oh, what should I round this to, right? We always look for the um, correct number of significant figures. So if you focus on the question, we have to look for the least number of significant figures from the question. So here we have two significant figures. Here we have three significant figures. Over here we have three significant figures. Then we have two significant figures, right? So when we provide our answer must have the least amount of significant figures. In this case, the correct number of significant figure is going to be 2. So we should report our answer in terms of two significant figures, and therefore 8.6 should be the best possible answers. So again, question 25 uh, and question 24 are different questions. So for question 24, you can still leave it as 0.862, but question 25, if you have to round this answer in terms of the correct number of significant figures, you should report it as two significant figures, which would be 0.86, or you can round this to, in terms of scientific notation, you can write 8.0 times 10 to the power negative 1. All right. So for question number 26, we have to determine the molarity of the acetic acid. Again, always look for the keywords for the question. We have titration is a keyword, neutralized is a keyword. It's very easy to make mistakes in terms of selecting the correct formula. So always look at the keywords, right? So some people would look at the word molarity and they might get confused um, based on the reference table T, which formula they should use. So if we look at reference table T, we have a formula for molarity, which happens to be under the formula of concentration. Molarity is moles of solute over liters of solution. Then we have the formula for titration. Uh, in titration, we also have molarity. MAVA equals MBVB, where MA and MB is molarity of the acid and bases. So you have to be very careful which formula you should use while solving these questions. So for questions like 26, I would highly recommend that if you see both words, titration and molarity, um, look focus on the word titration and use that titration formula, right? So focus more on the word titration so that you are not using the formula of moles of solute over liters of solution. Because it's an acid-base neutralization question, you should use the titration formula. So where MA is something we are looking for the molarity of the acid, so we are looking for MA question marks. The volume of the acid is right here, 10 milliliter, so that's the volume. So that's VA. Then we have the volume of the base, which is VB, and then we have concentration of the base, which is 0.64 sodium hydroxide, and hydroxide is a base. So we know VA, we know MB, we know VB. So all we have to do is to set up the equation. We don't know MA, VA is 10, MB is 0.64, and then VB is 12.5. If you solve this equation correctly, then MA, you'll get the answer MA as 0.8. Again, don't just look at the question, don't look at the solution. Try to solve this question by simply pausing the video and then check your own answer to see if it does match with mine. So for question number 27, you have to express or you have to state the number of significant figures used to express the volume of the acetic acid. So uh, that's the volume that we have to focus on. 10.00. So if you review the significant figure concept, you would know that 10.00 has 4 significant figures. So the correct answer for question number 27 is 4. So 10.00 has 4 significant figures. Question number 28, identify the positive ion in HC2H3O2. So if you look at reference table K, you would know that it is an acid, acetic acid, or ethanoic acid, or even in the question, they are telling you it's an acid. So based on Arrhenius theory, you need to know that, or even based on acid-base theory or one acid-base theory or alternate theory, all of these theories states that acid will produce hydronium ion. So your answer can be H2O plus, or you can simply write H plus, or you can write hydronium ion as well for your final answer. All right. So all of these answers is going to be correct. So for question number 29, um, the moment you see the word titration, you need to write down the formula MAVA equals MBVB. Then you have to look for what is given. So here we were given as sodium hydroxide. So I know it's a base based on reference table L. The concentration, meaning MB, is 2. The volume is 5, meaning VB is 5. So I know that all I'm missing is the volume of the acid, which is 10. And then I have to solve for the concentration of HCl. So everything except MA is given, and at this point you should be able to solve this question correctly. Please pause the video and check if you got the same exact answer as mine. My answer for this question would be 1 molar. For question number 30, again, look for your keyword. In this question, the keyword is neutralize. So that means we have to use the formula MAVA equals MBVB. And based on the question, now that you wrote down the formula, it would be very simple for you to figure out the given. So here we have 0.3 m of sodium hydroxide. Again, sodium hydroxide is a base, so 0.3 would be Mb. Then we have 15 milliliters, right, of 50 milliliters. So that must be the volume of the acid because it says HCl. And then we have 0.8 molar HCl, right? So that must be the concentration of an acid. So all we are left out with the volume of the base that we need to figure out. Plug in all the given in your equation and solve for VB. So I plugged the numbers. MA is 0.8, MVA is 15 equals MB is 0.3, VB is unknown. And then I solve for VB by dividing both sides by 0.3, and I got VB as 40. And again, keep the unit same. So the previous unit was 50 milliliters. So your final answer should be 15, 40, and you keep the same unit with the same liters. So do not change the unit unless you convert something in a different way. So the correct answer for question number 30 would be 40 milliliter. So I hope you understood all the questions that we went through for acid and bases. If you have more questions, please don't forget to ask me those questions. And hopefully I can explain it better next